Picture this. Right now, as you watch this video, somewhere in the world, molten gold is flowing at temperatures reaching 1,600 degrees Celsius, transforming from raw rock into the purest metal on Earth. Every year, humanity consumes nearly 4,900 tons of gold, fueling everything from the smartphone in your pocket to the most luxurious jewelry. But here's what will blow your mind. Behind every single gram of gold lies a journey so complex and fascinating that most people have never seen the full process. Today, we're going deep inside a modern gold factory to uncover exactly how raw ore becomes 99.99% pure gold. And trust me, what you're about to discover will change how you look at this precious metal forever. Before we dive into this golden journey, smash that like button if you're ready to see something incredible, and subscribe because we're about to reveal industrial secrets that will amaze you. Gold has mesmerized humanity for over 4,000 years. Ancient civilizations in Mesopotamia and Egypt were among the first to master gold extraction, using primitive techniques like cupellation, where they heated gold with lead in porous crucibles to remove impurities. By 2000 BC, ingenious artisans developed salt cementation, separating gold from silver using salt mixtures. But the real game changer came in the 19th century when the Miller process emerged in 1867, using chlorine gas to achieve 99.5% purity. Shortly after, the Wohlwill process revolutionized everything, employing electrolysis to reach an astounding 99.99% purity. These breakthroughs transformed gold from a craftsman's art into industrial precision. But here's where the real magic begins. The gold journey starts thousands of feet beneath your feet, in places most people will never see. Finding gold isn't about luck, it's about science. Geologists become modern treasure hunters, using cutting-edge technology that seems straight out of science fiction. They analyze geological maps, study soil samples, and deploy advanced tools like remote sensing and geographical surveys to detect the tiniest traces of gold deposits. When they identify a promising location, the real work begins. Massive crews move in, clearing vegetation and building access roads capable of handling equipment that weighs hundreds of tons. They construct entire temporary cities, complete with worker camps, offices, and maintenance facilities. Every detail is planned with military precision because safety and efficiency determine success or failure. Once the site is ready, miners face their greatest challenge: extracting gold-bearing rock called ore from deep underground. Most gold comes from lode deposits, where precious metal hides inside veins running through solid rock. This requires hard rock mining, a process that combines brute force with surgical precision. The assault begins with drilling. Workers operate massive long-hole drill rigs that bore deep into solid rock using steel rods and powerful drilling heads. Compressed air flows through these drill rods, clearing crushed rock as the holes penetrate deeper. Mining experts design each hole placement based on the site's unique geology. After drilling, explosives are carefully placed into the holes. When everything is secure, the charges detonate from a safe distance, shattering solid rock into manageable pieces. But breaking the rock is only the beginning.
Mucking machines, resembling mechanical monsters, scoop up the broken ore and transfer it into ore cars.
These cars carry their precious cargo to mine shafts where it's lifted to the surface, beginning its transformation from worthless-looking rock into pure gold.
Here's where the real transformation begins.
Once ore reaches the surface, it enters the processing plant where the first job is breaking it down into smaller pieces. Large crushers devour big chunks of rock, crushing them into gravel-sized bits. This might seem simple, but it's absolutely critical because the next step depends on it. The gravel moves to grinding mills, and this is where physics meets chemistry. These powerful machines use heavy steel balls and rods to grind gravel into powder finer than beach sand. Why is this so important? Because grinding dramatically increases the surface area of the material, which is essential for the chemical processes that follow. The more finely ground the ore, the easier it becomes to extract every particle of gold hidden within. Now comes the most fascinating part: chemical extraction. The fine or powder is mixed with water, creating a slurry that flows into large tanks. Here's where things get seriously scientific. A cyanide solution is added because cyanide uniquely reacts with gold particles, dissolving them into liquid form. To accelerate this reaction, air is pumped into the tanks through a process called aeration. The oxygen triggers a chemical reaction between cyanide and gold, forming a gold-cyanide complex that blends into the surrounding liquid. This step is controlled with incredible precision because operators must extract as much gold as possible from every ton of crushed ore. The result is a liquid rich with dissolved gold, ready for the next crucial stage. The slurry flows into large rotating drum filters that separate liquid containing dissolved gold from solid impurities. The filtered liquid then undergoes recovery treatment where chemicals like zinc, carbon, or aluminum are added. These substances react with gold ions, causing solid gold particles to form and settle out for collection. But we're not done yet. The collected gold particles still contain impurities, so they need smelting. The gold concentrate is combined with special flux materials including manganese dioxide, silica, borax, and sodium nitrate. This mixture enters a high-temperature furnace heated to around 1,600 degrees Celsius. As temperatures rise, everything melts, but here's the beautiful part. Because gold is denser than most materials, it naturally sinks to the bottom while lighter impurities, called slag, float to the top. Workers carefully remove the slag, ensuring no gold remains. The molten gold at the bottom is poured into molds, forming bars called door bars. At this stage, gold is about 80% pure, impressive but not enough for commercial standards. To achieve the purity levels demanded by industry, refineries use advanced techniques. The Miller process passes chlorine gas through molten gold, reacting with remaining impurities to form compounds that separate from gold, typically achieving 99.5% purity. For even higher purity, many refineries use the Wallwell process, involving electrolysis where door bars act as anodes in special solutions. As electric current passes through, pure gold deposits onto cathodes, reaching purity levels up to 99.999%. Once refined, gold undergoes rigorous testing using methods like fire assay or spectroscopy, ensuring the final product meets international standards. Quality control is absolutely non-negotiable because gold's value depends entirely on its purity. The final step transforms refined gold into usable products. Gold can be cast into bars, minted into coins, or shaped into jewelry and industrial components. Each product must meet strict standards for weight, purity, and appearance. Gold bars are sealed in tamper-evident packaging that includes assay certificates confirming weight, purity level, and unique serial numbers. Coins receive protective capsules or blister packs preventing damage, along with certificates of authenticity. For luxury items, packaging becomes an art form, with high-end boxes made from fine materials highlighting the gold's value and craftsmanship. This packaging does more than protect the product. It verifies quality and provides assurance to buyers and investors, completing the incredible journey from underground or to pure gold. So there you have it, the complete journey of gold from deep within the earth to its final gleaming form. After witnessing this intricate process involving explosive mining, chemical reactions, furnaces burning at 1,600 degrees, and precision refining, what do you think holds more value? The precious metal itself or the remarkable process that brings it to life? Share your thoughts in the comments below, and if this journey amazed you as much as it should have, hit that subscribe button for more incredible behind-the-scenes content that reveals the hidden world of manufacturing and industry.